I call this segment Cacti in the Rain. Man, been lightning like crazy today. Rain, just pouring rain. I hope you didn't see that notification. I hope this phone doesn't put my notifications in a video. I want to show you something. Hang on. Now, poor Scout, he's hiding under my desk. And what I'd like to talk about right now is my approach to changing components on vintage electronics. I mentioned J-hooking, the J-hook. You know, to some it's utter blasphemy. To some it warrants a visit by the Heathkit police and the purists. I gotta clear my throat. And the Heathkit police and the purists, now their faces are like chiseled out of granite. They don't smile. They know no humor. And but I don't worry about that. On vintage electronics, sometimes I do use the J-hook, and for very good reason. Now, I'm going to be doing a lot of pausing you, and I hope I can zoom in and get some kind of view. I hope, because I want to try wiggling a couple things while you watch. So let me zoom in on the first area of interest. Hang on. Okay, I opened the sliding door a few inches, hoping you'll be able to hear some thunder. Okay, now then, J-hooking. When would I J-hook a component that's being replaced? Let's look at this terminal strip right here. Right here. These terminals are very strong. I would never worry about breaking one by unsoldering a lead. You can still buy those. I'd hate to change them, but you can buy them. But look at this top connection right here. You've got a couple capacitors connected to that lug. You've got an RF choke. You've got this capacitor connected to that lug. And by the way, that capacitor lead, look where it's attached to that lug on the bottom of that pile. You know what I mean? You've got how many things soldered there? 1, 2, 3, 4, and a wire. And wires. Let's talk about wires. I don't like to redo connections that have a wire. I try to avoid it if possible, because you end up melting the wire. And then what are you going to do? You've just made it look ugly and cooked and worked on and screwed with. This is a strong terminal. If I had to replace this capacitor, and I will, do you think I should start unwrapping all these leads to get to the bottom of the pile? Disconnect everything? You could. I'd hate to. What will I be doing? Not that. This lead to this capacitor, I'll cut it. And you make two, and you make a J. You make a little hook on it. And on your new component going in, you do so on that lead too. And you just put the two hooks together, take your needle nose pliers, squish them. That makes your mechanical connection. Then you solder it. And that achieves your electrical connection. But you do what you'll do. I would rather not unsolder all of this. You know, you could always try melting the solder and, cut this lead and try unwrapping it from below. Good luck. So that's terminal lugs. That's my approach to terminal lugs. I'm going to reposition you and show you something else. Hang on. Okay. These two resistors right here, this 47K and this 470K, they both need to be changed. They're out of tolerance. And what's my approach here? At a tube socket? Well, this radio isn't that old. This radio was made in 1976. And These tube sockets, although I'd hate to break one, they're well, I don't know what they're made out of. You tell me. The terminals are strong. Now here's one with just a wire connected to it, and I can barely move it. See, that is strong. I would not worry about disconnecting components. And I'm going to zoom you in on this area right here. Hang on. You can't really see it very well, and I can't see it at all because I'm sitting behind the camera. But it looks like this lead comes down and bends up and comes right back up. And very typically, that's how people made connections to tube socket pins, because many of them don't have a hole in it. You don't pass the lead through the hole. It's not how you use the tube socket. You wrap the lead around the lug and solder it. And usually people don't wrap it all the way around. Usually people make a J on the end like that resistor has and solder it. So when I replace these two resistors, you know what I find to be the easiest way? If I'm going to disconnect that lead, I'll either cut the lead up here or preferably cut the resistor right in half. And then when you melt the solder blob on the tube socket pin, you can grab the end of the resistor, that half of the resistors, and it makes it much, much easier to get both ends off if you cut the resistor in half. So that's my approach on tube sockets. And once again, like this wire right here, it's the only connection on that tube socket. But if there were, say, a capacitor hook there that I had to change, I'd really hate to melt that wire. It looks pretty. This is what happens, and a lot worse. You can always tell how a Heathkit's been, how lovingly it's been repaired in the past. But anyway, I want to... So those two resistors, the terminal strip has strong lugs. I'll just be cutting those two resistors in half and unwrapping both ends. No problem. Let me find another point of interest. Okay. This Hallicrafter is S120. Isn't that old? But I'll tell you what, you're never going to buy a new band switch for this thing. This band switch is once you ruin it, it's gone. It's like your liver or your heart. These terminals on these band switches, I don't know if I can actually make you see it move. Look at that. Look how flimsy that terminal is. I do not want to destroy this whole radio by destroying the band switch. And the same is true of Heathkits, of course. And by the way, you do not ever spray this band switch with deoxit. You'll destroy it in time. This will absorb the deoxit and it will fall apart. It'll swell. Yeah, you don't use chemical cleaner. Well, you could use naphtha, which is white gas, Coleman fuel. It's excellent. You could use acetone. Anyway, I digress. Very, very fragile lugs on those contacts. I guarantee you, if I will be replacing... Let's look at this part, for example. The hell is it? There's no dog bone. It's resistors. It's got to be a cat. Whatever. Could be a molded choke, but I doubt it. That lead right there is about a ½ inch long. And it's just long enough for me to cut this, if I were changing it, to cut that right there, make a small J, and connect my new component that way, rather than destroying the whole radio by destroying the band switch. And the same is true of any part connected to that band switch, you know, that, anything. So that's band switches. find another point of interest. Yeah, I see it. Hang on. Right. Now this, it looks like an IF transformer, the bottom side of it, and it's identical to one, but it's not one. This one could be an IF transformer. I don't know the topology of this receiver. It's got to have them. But they use the same type of can as a variable inductor, I've noticed in this radio. But regardless, as with the band switches, if you go destroying IF transformers, you'll probably never find one for it again. I just saw a lightning bolt. And like these terminals, they're small and they're fragile. Boy, I'm shaky. Dang, man. Let me move that green wire. Look at the terminal. Move. Look at that, man. It's loose in the can, in the part. You know, it's already loose. The wire's not melted. See how pretty that green wire is? You really want to cook the end of it and make the insulation all peel back? I don't. But you might have to unhook that wire if you ever have to take the transformer apart to service it, like if it has silver mica disease. Look it up on YouTube. You'll see what silver mica disease is. But some of these, I don't know if this resistor's out of tolerance or not. I can't get my hand in there. This one, I don't know if it's right here. If it is, though, I'll cut the lead right there and J-hook it. I'll be J-hooking a lot of parts in this radio, just not the components that hook to a terminal strip. If a component hooks between a terminal strip and a transformer like this, then I'll J-hook one end and unwrap the other. I'll make a hybrid. Let me look around one moment. Okay, guys, so given what we just talked about, let's look at this resistor. Will I J-hook either side of that? Yes, most definitely this side, because of that transformer connection. I don't want to destroy it. But this tube socket right here, these are pretty strong. I'll probably try to unwrap it. I'll see how it goes. If I have any trouble, though, I'm not going to try hard either. I'm not going to start roasting things. I'll try to unwrap it. If I have any trouble at all, I'll just resolder it, cut the lead, and J-hook it. Well, let me look around. And oh boy, you're looking at something you should never try to desolder the components from. I've always called them loop stick coils. Radio Shack used to sell them. Well, not them. They used to sell one for experimenters, one type. But they're called loop stick coils. And man, these things have some exceedingly fragile little contacts. Not contacts, but you know what I mean. Little loop of metal to make your connection to. Man, some of these have some fine wire on them, and this will break off so easily. And hang on, look how many there are. You know what I mean? Here's 4, here's 3, that's 7 of them. I don't want to destroy them. If any components need to be changed that are soldered to those, I will not unsolder that lead. Nope. Right now, I don't really see any, but I will not be unsoldering any leads from those coils. People like to call them unobtainium, and they certainly are. And there's 6 of them in my HW16 that you're looking at right now. Not going to destroy them if there's a component lead soldered to it. I got to find a pointer. Oh, I can't see like this guy. Not unsoldering that lead. No. And really, guys, anytime you're going to change a resistor like this one, just simply between the volume control or a pot and the switch, you're really better off just cutting the resistor in half and then removing each half. It's so much easier. Look at all the connections made at this IF transformer CAN terminal. You know, 2 resistors, a capacitor, a wire. Man, I would never melt that blob. Bob the Blob stays. By the way, capacitors don't go bad, do they? Well, I used to maintain a whole fleet of IMED 927 and 928 IV pumps. Oh man, we had like 240 of them in the hospital. The IV pumps had 3 boards that were stuffed with TTL logic and capacitors, and the caps were there to de-spike the supply rails on the boards, right? And decouple spikes around the components. And there were spikes too, because it had a mechanical counter, like that, you know what I mean? That had a coil in it. Capacitors were by far the most failure-prone component in the machine, even though it had 10 million logic gates. Anyway, I digress. Hang on. This pot right here is terribly, it's wasted. No, not that one. This one right here. It's a BFO pot. It's wasted. Man, it was fun to use my VTVM to check it. You wouldn't believe it. You should see how terrible it is. I guess that's all I wanted to say. You guys know what that is? If you do you know how to pronounce it? Some people call it a couplet. Some call it a couplet. What say you?
It is the springtime of my loving, the second season. I'm to know you are the sunlight in